it seems that apparently it should appear on streaming now. Let me see if it's correct.
As the meeting stream is live on YouTube message.
Yeah, so it apparently it is, right? Cool. So technology is amazing. So let me see if we can start. Yes, so I guess, Vadim, you can see my screen, right?
Yeah.
So let's wait one more minute and then, because then I cannot copy the video of YouTube. Where is this? I will say, yeah, so that's it. This is the presentation, and then let me have a second, because then it could make sense not to tweet something about it. Yes. Let me see. Something like this. Okay, I will copy this later on and press the button when you start talking, if you don't mind.
I can't retweet because I'm concentrated on the talk. So probably I
Makes
want to ask this is
makes
not okay if
makes
I like the post during my own presentation.
yeah, make totally sense. Yeah. So yeah, so let's start then. So as many people know, we normally explain a little bit what's the. So first of all, thank you everybody for joining another Barcelona Java User Group meeting. So I hope everybody will enjoy it, and let's see how it goes. So as many of you know, we are basically a bunch of geeks that wants to share and learn a few things, almost everything related to technologies. And also we are a non-profit association since almost 8 years ago. So yeah, we basically meet and discuss about frameworks, technologies. We try to basically grow as a developer and almost everything related with Java, but not only with Java. So yes, probably all of you will arrive to here based on the meetup or probably with thanks to Twitter, etc. But we have a lot of places where you can join us. We have a Slack channel, a great way to contact people, to share things, etc. And also probably Twitter yeah. So the website is basically our blog, pretty much. So yeah, we did a lot of events last year mainly because of the COVID-19. We are moving to the remote way, but a lot of them related somehow with microservices, Java libraries, frameworks, methodologies, etc. And yes, so we did some events, some, let's say, I would say big events, like this huge conference that we did well, last year, if I'm not wrong, yeah, May. And yes, we did this year. It was not possible to make it, so we moved to the 2021. And yeah, it was really funny and really engaging. I think in terms of how many people came, how was in terms of people engagement, and I think curious about many things. And I think we learned many different things. So yeah, this is part of the team that we've been working there. It's a great effort, and I think many of you may know a few people here. So yeah, that's it. So for the next year, yeah, we are gonna try to make it happen in July, crossing fingers. And yeah, it's summer, so who knows how it's gonna work this. Yeah, for this, I will say that I have to say thank you to Dynatrace because and JetBrains, they are helping us with the Zoom thing, for example, Dynatrace, and JetBrains is going to help us providing some licenses. So if you want some license, ping us, please. If someone needs a IntelliJ license, we have some to do a raffle. And I think that's it for now. We want to invite everybody to contribute to help us. So ping us if you want to talk about something that you've been doing or a particular project or just a simple snippet. We can move instead of a 1 hour talk for something really small, and then we can discuss and do these kind of things that could be probably more interesting, more engaging, and we have more talks during this time. So that's an idea. If you want to have a look, yeah, think about it, and I think we can do it that way. And yeah, for the things that if you have some questions for Vadim, sorry, during the session, I can recommend you to go here to this link Slido 5555. So 5 5s and 4, and then basically ask the questions there, and we can recap then and get all the questions and then move back and try to answer all of them. And yeah, that's it. So I was to say that thank you very much, Vadim, for your proposal, for your suggestion, and for being here to waste that time when you are not at 100%, I would say. a bit
Not waste of time.
you're fine. Okay.
It's
And yeah, so basically probably it's much better if you can introduce yourself while I'm stop sharing. So thank you once again. And yep.
so we wanted to start with some kind of questionnaire, and then I will go to the talk, and then as a part of it, I will introduce myself. So Nacho and me, we thought that you see my shared screen, I think. So this is the link where we ask you some questions because they are really relevant for me to frame the conversation. How much experience do you have? You are Java savvy community, so I expect the experience in Java, but the talk embraces three different spaces: Java, AWS Cloud, and serverless on AWS. So it's also so important for me to somehow understand what are your experience. So if you have some time, please visit this link and answer your question. I think we can give so several minutes, and then I can look at the results and share them with you, and then probably I can understand better where I have to go deeper or even know something like this. I think that the link is very easy to capture. I think three minutes are enough. There are three questions, I think, so it will be nice if you can answer them.
Yeah, and also the people can see the results. So probably it's interesting to know how many of us have experience with serverless or how many doesn't have experience with serverless. And yeah, so let's see. You can see the reply, the results. So I think you can also start having a look if you want, Vadim, on the results that it because
Yeah, then I will probably go there and then share another screen. So should I,
yeah, so you have to answer
I have to
to
answer.
see. That's so some feature that we forgot.
That's okay. Uh, it will be interesting if I will answer. I don't have any experience, but I want to talk about the talk. So little no bisher. So okay, I have
Yeah.
everything German because yeah, because I'm living here.
So
So
majority of the people I would say they use as a proof of concept, no?
okay, many people did proof of concept, and then Java. Okay, JavaScript. Okay, and 12%. So I will assume two people don't have any experiences. Okay, so we have probably, as expected, some kind of mixed situation. So I will then jump into the presentation. So I have to share this, and now you probably see this. I would like to go to the presentation mode.
Yep.
Now you see the full screen, I think.
Yep.
Yeah, so you don't see the presentation mode. That's a very cool feature for me, that you see the full screen and I see the presentation mode. So you see the laser, I think, yeah. So I can point to some. Do you see this red thing?
Yep.
Okay, so I probably am ready to go. So thank you very much, Nacho, and the community for inviting me to talk about adopting Java for the serverless world. And I will take the perspective of AWS developer. It's the new talk which I had to present for some conference, and it's the first run of it. So probably not everything is fine, and I really encourage you to give me feedback to improve the talk and so on. But it's really cool that I can start there with you. So yeah, my name is Vadim. but just I'm Ukrainian native, but I spent half of my life in Ukraine and then the half of my life in Germany near Bonn. So you can follow me on Twitter if you wish, and it's not surprisingly I am tweeting about Java and mainly serverless in the context of AWS. I'm also the co-organizer of Java's user group and serverless meetup Bonn. So Bonn is near Cologne in Germany, so we are 20 minutes away, both cities. But we are currently pausing due to Corona, so we don't have any events. Just because, yeah, it was so engaging to have the community there, and currently we can't organize anything. Hablo un poco español porque soy admirador de Julio Iglesias. Empecé a aprender español hace muchos años para entender sus canciones, pero ahora vuelvo a cambiar idioma y hablar inglés.
Oh, well, I think this is the first time I have seen somebody who have learned Spanish thanks to Julio Iglesias. This is an amazing way of starting the presentation.
Yes, visité sus performances en 6 o 7 veces in different países. So just, yeah, I will switch to English, not to blame myself, but just to learn Spanish was important part of my life for several years, one evening in the week, and I really loved the country. I really loved the language. I visited Barcelona, Tarragona, Mallorca different times with the family. So I'm really in love with your country. That's why I offered the talk to this Java user group, because just I have the connection to the country and to the city.
Cool.
So that was some kind of my thoughts.
Great. Just perfect. Continue. Sorry.
No, that's fine. So hopefully I didn't make too many mistakes, but
no, that was correct.
Yeah. Okay. So just yeah, I'm working for middle-sized company, IP Labs. We are writing software for designing and ordering of the photo products like calendars, photo books, prints, posters. So everywhere where you can print the photos for your memory, and we are with all modern platforms. And we are the 100% subsidiary of the Fujifilm in Europe. Founded 15 years ago, 80 people, 30 developers. And we are mainly doing. We started just like many companies with Java, Spring Boot later, but now we switched to AWS Cloud, and since 2.5 years, nearly 3 years, we're experimenting. We are doing also things live with serverless, but mainly currently not with Java, with Node.js, but of course we are thinking, because we have invested a lot and we have savvy Java developers, so we are looking for the ways to come back with Java, and that was my motivation to create this talk. I'm very active in speaking, mainly with AWS talks and so on. So you can find me on Twitter, YouTube, and so on, different topics like hardware, memory, then reactive applications, and later about serverless and productivity. So now we can really jump into the talk itself. So just we will start with some kind of numbers to frame what is the current situation with Java. So of course, there are a lot of statistics, and if you see this popularity of this language, there are totally different statistics because they capture them in totally different manner, like Stack Overflow questions or some kind of search or job search. So totally different results. Probably the right one will be something I would say I can understand this more, because on the left side you have C++. So I don't really know if it's the fourth or not, but you see that the adoption of Java is really huge. So something the first or the second place, and this is some kind of around 20%. And I think that's something what I also know from people. One of 5 people really program Java. If you will look at AWS and serverless, then you see the Amazon Web Services is the most popular cloud provider. There are different categories like infrastructure as a code, platform as a service, and so on. But generally speaking, they are ahead of other cloud providers for 10 consecutive years. and you see there are no challengers. So we have big three, and then many way behind. So then we have Java as very popular language, and we have AWS as the most popular cloud provider. And then we look at other statistics, and you see all the links below. And I will of course share the presentation itself. It's not only will be recorded. I will post the slides on slide share, so you can look at them and ask questions. And yeah, you see that the questions were the recent survey, what serverless vendor do you use? And you see the first place, without any doubt, AWS Lambda, so the serverless solution from AWS. And the participants were also asked to answer what they intend to use next year, similar comparable situation. So serverless offering of AWS is way beyond others. And you see the rise of serverless. So just in the last 2 years, it's exploded. As we started with our company, it was January of 2018. I think we have some kind of productivity week where we could decide what to do to help the company to fix the problems and to implement new things. It was the trigger for us to implement one application the serverless way. Nacho shared this picture on the meetup as he presented this talk. This was this project, like revenue share project. So he probably stolen this from my other presentation, which is totally fine. But this was the first project which we did with serverless and even with Java, because it's costed not too much with all the problems we were talking about. So we have rise of the serverless, and now we are talking about life of Java serverless developer on AWS. Generally speaking, you have version support of Java 8, even with long-term support, just as the Amazon Coretta is the offering for long-term support, similar to Adopt OpenJDK and so on. And it's even adopted for Amazon Linux operating system and so on. So they fix bugs, or even improve things, especially for AWS. And we have support of Java 11 since the end of the last year. And if you compare this to other cloud providers, then it's really good situation. So I know that Google offered Java 8 last year as a beta, and Amazon has had Java 8 since 2 years, and Amazon had Java 8 since 2015, I think. So just what Amazon offers, it's really quite comfortable comparing to all other situations. And what we see and what we know and why we love Java, it's really fast and mature programming language. But its serverless adoption on AWS or even generally looks like this. And you see the percentages, and you see they are not, if you sum them up, there will be more than 100%, which probably says that some companies use different languages in parallel. But what you see, that Java is way behind Node.js and Python. And this is something that I can really confirm. That's my experience when I talk with people. There's something, the adoption is not 20%, but way below 10%. And just another survey says generally the same. They provided two numbers last year. The first number, if you see for each language, is percentage of function monitored, and the second is percentage of invocation monitored. So we can ignore the second number, but we see just the same picture. So Node.js and Python are way beyond Java in this case. So just it's probably not very good situation. We have rise of serverless, and we can't use our favorite language, or can't use that much. And we will be talking about why. And generally speaking, developers love Java and will be happy to use it for serverless. Just several minutes how we can create AWS Lambda, like function as a service. With Java, it's completely similar as with other languages. So we can select runtime Java 8 or even Java 11, and then we should give the function the memory up to 3 gigabytes within 46 megabyte chunks. And we can also select timeout, so to say the function cannot take more time than 10 seconds. And we have 15 minutes maximal, and we will look at pricing and see why it's relevant to think about these timeouts. So generally speaking, simply the simple function. It doesn't matter what it does. So there are two possibilities to create the function. On the left side, you see how you can do this with LWS SDK. So you simply implement the interface request handler, and on the first parameter is the request, which will be the object, which will be automatically mapped within JSON, and the second one is the output. So, and then you implement only one method, handle request, which takes this request as a parameter and calculates something, and then you give this response like you give this. Another possibility, which is in Java 8, you can implement function interface from Java 8, from Java util function. That's the same. Then you have the apply method, and what you lose there, this context parameter, which comes from SDK from Amazon, which can give you some context, even more BQM information. So but generally that's similar. We will see both approaches when we are looking at Micronaut and so on. You can interchange them, but generally speaking, that's one function which takes parameter, calculates something, and returns it. So now, what's the problem with Java generally? Yeah, the first problem is so-called cold start, and it's really big, and it's bigger than other languages, dynamic languages, and depending on the situation, I will explain what is the cold start, and the cold start occurs with each language. It doesn't depend on Java. And if you use AWS, the first thing you have created a completely new function, which hasn't been executed before. Then what happens? You upload the code to some storage S3, and then if you want to call the function, this code should be downloaded. Then the container should be started. It's not Docker container, it's Firecracker in the case of AWS. And then the runtime should be bootstrapped. And runtime is the runtime which we selected. In our case, it's Java runtime. Yeah, and you see these three steps are so-called cold start. So this happens if you don't have enough containers to handle the load. So the function, only one function can be executed in parallel. So if you have 10 and you don't have 3 containers, so the new container has to be started, and all these 3 steps should occur again. And the last step is only the function call. It's warp start, and these 3 steps are called cold start. And what is happening exactly within this bootstrap phase? If you bootstrap the Java runtime, the first thing, AWS Lambda starts the GVM. So yeah, there is no environment. So first of all, JVM should be started. The second one, Java runtime loads and initializes handler class. So this one class, this function class, which implements this interface with handler request method or function interface, it should be initialized and loaded, and all dependencies should be loaded. And the first thing, that this static initializer block will be loaded. Yeah, each Java class has the initializer block. And the thing which happens there, what you should understand, is that in the initialization phase, you have access to the full CPU up to 10 seconds. And it's very important that you can speed up execution there. And generally, if you select the memory, and you see here on the slide, then you will be assigned the CPU proportionally to your memory. And only if you select something 2 gigabytes, then you have access to the full core. So if you have the very small function, where there is enough 128 megabytes and so on, you only have the fraction of CPU to run the handler method. And if you can initialize things in the static initializer block, or you can do some calculation, then do this, because you have more CPU. And that's why you can even speed up things, and you can delay cold start. We will be talking about this. And the last step, Lambda calls this handler method. There you have your business logic, and there you see that's what I have said. So you don't have, normally you don't have such lambdas that you use 1.8 or 2 gigabyte of memory. So you have smaller one to do the basic calculation, but you don't have only access to not the complete CPU, but with a fraction of CPU. So that's one important thing, what happens in this bootstrap phase. And then if you start your code means Lambda calls the handler method. So now there are a lot of statistics, and it's probably the recent one about this cold start per programming language. It's much more complicated than only this, but generally you see Java has much higher cold start times comparing to JavaScript and Python. And this is one of the reasons why probably people some kind of avoid Java. And the thing is, this is very simple view, and this is, yeah, you will have 1 second or below only for very simple applications like hello world, but nobody writes these applications. So it goes significantly up with more complex scenarios, like dependencies to multiple open source projects should be loaded, or you use you instantiate things to communicate with other services like AWS services, DynamoDB, SNS, SQS, third party. If you add up some complexity, you will experience the significantly higher cold starts, and they can go even up to 10 seconds and even more. So this is something which Node.js and JavaScript, like dynamic languages, that don't have this. And to achieve the minimal cold start time, you have to apply all best practices we will be talking about. And yeah, that's really the case that you can have even more than 10 or 20 seconds of cold start. And I am referencing here the YouTube video of Stefano Bugliani from AWS. He explains that he was on call with this huge cold start and had to fix this. And we will go also through his suggestions and other suggestions. So, and if you will see on this report, and the report is from New Relic, and you see what is here highlighted in red, they say they expect the adoption trends for Java to increase in this year. And they explain this, that there are 2 features released from AWS, like provision concurrency and VPC improvements, which may help us to reduce all the problems or to eliminate or some kind of to be in the better place. And we currently will be talking about all these improvements and all these problems to understand this in depth. So the first thing was provision concurrency. So imagine the situation that it's 9 o'clock in the evening and your company sends the newsletter. And newsletter will be sent within 1 minute, and everybody sees this and everybody clicks on the newsletter and goes to the page. So you have some kind of huge spike. And if you would like to avoid this cold starts and the people going in parallel, then you need to have more containers in parallel, and every container will experience the cold start. Then it's probably not a good place to be. In case of Java, if you have this 10 seconds on something like this, nobody will wait. So many people will leave and you will probably lose money. Then AWS released probably the end of the last year this feature provision concurrency. And what you can do, if you know that you from time to time you need to have warm containers, so you can provision extra containers to stay there, to be warm, and to be ready to execute only your business logic. And then you can say you need so many containers on so many functions warm from time X to time Y and to time Y. And then, of course, you have to pay for them, and you have to manage this logic, like, yeah, to say, even to say when you need the containers and then they don't need for not to overpay and so on. But this is one possibility to say, if you know in advance that you will have the huge spike for several minutes, for several hours, you can decide to overpay. And it's really good for languages like C# and Java. The second one is Lambda behind this virtual private cloud, VPC. I won't go into the details what it is, what is virtual private cloud, but you see that sometimes if your Lambda communicate with other AWS services, it requires to put the Lambda with this behind virtual private cloud. And these services are relational database, Elasticsearch for Elk Stack, and Elasticache. And I don't see many people using Elasticache and Elasticsearch from Lambda. there are other possibilities, but many people really use relational databases, and then you are forced to bring this relational database behind virtual private cloud, and then you are forced to bring your Lambda behind virtual private cloud. There is only one exception, Aurora Serverless Data API, where you have a relational database which don't need virtual private cloud. You can communicate with this like with HTTP, like with DynamoDB, but it's only one exception. What was the problem with if you have this scenario, if you don't use like DynamoDB, like NoSQLDB, and you say, I'm really savvy with relational databases, then 1 year ago, you ran in those situations that if you have many Lambdas in parallel, then AWS service had to create a lot of network interfaces in parallel, and this creation took extra time. So you had the cold start of Java, and then you had additionally cold start of the VPC, and it took really 10 seconds. We have measured this, so you had the combined latency of 20 seconds, and it was really no go. What AWS did in the end of last year is to create this network interface, not when you are calling the Lambda, but when you create Lambda, when you deploy Lambda for the first time, or you update some settings. So it's some kind of eager creation of network interface. And if you deploy your Lambda, you don't call it directly, generally. So then AWS had time. And this reduced this cold starts from 10 seconds to really below 1. And this change is, I think they have rolled out this everywhere in the cloud. So in each region, and this is a huge, really huge improvement. So now people can think about using Lambda behind VPC, using the relational databases. There are other challenges, but generally this was a huge improvement, and that's why you really says in the report that now there are situations, so you can now use Java, or it became easier. It's not no go more, but there are other things to consider, or other improvements that people suggest, and which I have tried out. So the first thing, the old AWS SDK 1.0 for Java, it was not really good. So use this the second edition. So there you have lower footprint, and it's more modular. So you can exclude things that you don't need if you don't communicate with SQS and other services. So exclude them, or really only include services within this SDK that you really talking to. Like if you have Lambda talking to DynamoDB, then you can include only DynamoDB client. Another improvement to this SDK is to allow to configure HTTP client of your choice. So you can use even basic HTTP client of Java. You don't need native, you don't need Apache HTTP client with caching and so on, because with Lambda you only have one connection. It's one function, and you need only one connection to the to your service, and it should be as simple as possible, because other solutions, they scale better, they are really better for server application, but they are not a really good fit for function and serverless, which are really short-lived. So another thing is initialize and prime dependency during this initialization phase. And that was the thing which I told you previously, that you have the access to the full core for 10 seconds, but you can do a lot in 10 seconds with Java, and then use everything, initialize everything statically, what you need. And there are other really dirty tricks to do this. I don't put it on the slide, but I can explain. For example, in case if you first time call DynamoDB within your Lambda, then only then if you put something in DynamoDB table, then only then some Jackson marshallers will be some kind of initialized, and it costs really 1 or 2 seconds, because these Jackson marshallers are really expensive. So there are people which suggest the trick to initialize and do some fake call to DynamoDB in the static initializer block of Java. So some kind of fake call, some kind of put, or some kind of fake get to perform this. So it's the operation which doesn't have any sense, but with one completely core, it will be speed up, and then you won't experience this cold start time. So these tricks are mentioned here in the link, so you can read about it. It's really dirty. So clean Java developers would say no go, but sometimes we have to tricks currently with Java to be able to reduce these cold starts. Otherwise, it's really not a good solution. So other things to consider, you know many things, so you know you can build, if you build some clients, so you can provide credential provider, region and endpoint, and it will speed up the creation of this client. Otherwise, AWS need to auto detect in what region you are currently hosting, what Dynamo endpoint you want to call, what is default credential provider. There are a lot of so they have this some kind of fallback to get the right credential provider. But normally you know what you mean. So put this implicit. Don't offload this job to AWS to guess this. And of course, less dependencies, classes is more. So try to exclude everything that you don't need, because loading this will cost you time, and you don't have time, and you will see also why. And time is money in serverless, and then we will see this. So try to be as minimal as possible. And one of these possibilities is to avoid reflection. And of course, you will ask, how is this possible? I love Spring, or I love Juice, and something like this, and they're using reflection a lot. So probably ask yourself, do I really need some kind of dependency injection framework, or I can use plain Java in my functions? But nevertheless, you have the possibilities to use other dependency injection frameworks like Dagger, which are simpler, and they are really not reflection based. Or use other frameworks we will be talking about. So just keep in mind that reflection is something which also costs you time. Of course, strive for the cost optimization. And it's really also a huge part to think about costs. We are in the cloud, and with serverless, the costs are unbounded. So yeah, if you have instances like EC2 instances, you can say I have only 2, and I know how much does it cost. In serverless, you can simply scale infinitely, but it also scale your costs. So we will briefly talk about AWS Lambda pricing model to understand this. And you have really 2 dimensions: the request dimension, which is completely independent of the language, how much calls do I have, and then the duration. And the duration is, of course, language is a factor. So you pay, and depending on the region where you're hosting your application, but generally you pay 20 cents for million requests, and you pay this amount. I can't really I don't know how to pronounce this, but generally this is the amount that you pay per gigabyte second. And what is gigabyte second? This is the 1 second is duration of the execution, and gigabyte memory is the memory assigned to the function. And in AWS, the situation is that you have to decide how much memory to assign the function. And if you use less memory, you will nevertheless you will pay for assigned memory. So you have to. We will talk about how to do this and how to check what's the right amount of memory is. But it's not a solution always to assign 3 gigabytes of memory, because it will cost you money, even if you only need half of the gig. So that's something that you should, and the duration is really the duration of the execution that will be measured. I know that Azure and other cloud providers, they also measure the amount of memory you use, so you don't have to say I need 1 gigabyte memory or something like this. But in AWS currently, it's really different. So this is example: you have 1 million requests, and you assign half gig of the memory to your Lambda, and the execution takes 200 milliseconds. Then you pay for request here 20 cents, and for million requests with 200 milliseconds, you pay $1.67. So that's how to price this. And of course, the cost scales linearly with memory. So if you assign double as much memory, then you will be paying for memory double as much. And the question is, more memory, more expensive? Yeah. And the situation is that with more memory, you will proportionally get more CPU. You see there, your function is allocated CPU proportionally to the memory configured, and even network bandwidth will be allocated proportionally if you store something on S3 and so on. And this is very important information, because if I have more CPU, I can be quicker. And then if I'm quicker, and this is the duration, then I also, maybe I can pay less. And there is a really cool tool from Alex Casalboni, who is working for AWS, which is called Lambda Power Tuning. This is workflow that's with step functions you can automate, and you can assign to your function different memory settings, and will run this with different memory settings and tell you which setting is really the best from the pricing perspective. And if you assign double as much memory, but it's double as quick for nearly the same price, then assign more memory. And we have experienced that the perfect memory allocation is 1 gigabyte. So this is something there we have really the best situation from cost and speed perspective. And keep in mind, if you assign more than 1.8 gigabyte, then the second core will be activated. And you have to write the code which uses the second core. So otherwise, if it's everything is, there is nothing in parallel, then the second core won't be used. You will be only paying for the memory too much. So just something like 1 gigabyte, probably the half of the gigabyte are the best memory settings which we experienced in our application. But with this tool, you can really figure out what's the best situation for your particular Lambda. And just really fresh thing from my German colleague, I can't say colleague, but I know Stefan Grunwald, also from AWS in Germany. He wrote the article last week or the week before the last week about how to monitor the Java virtual machine. And he fetches the metrics from the garbage collector and visualizes them with Elastic Search. And then you can also see what is the optimal memory case in this situation. So you can download the code and set up everything. And it's the alternative solution to see how your function behaves in production. Do you really need as much memory as you assigned or not? So cost optimization, we know Java is well optimized for long-running server application. And then you have high startup times and high memory utilization. And as we've seen now, both are dimensions for paying. So if you pay for startup time, you pay for high memory, and that means costs. And we will be talking currently about how to reduce this cost, how to deal with this. And now GraalVM enters the scene. And just what it is, probably many of you know because it's a so hot topic, but we will be only talking about the aspects which are relevant for the serverless application, not general for every GraalVM. So they have many goals, like footprint and the ahead of time mode, which is really interesting. We will be looking at this. High performance for all languages, which I don't really know that people mix the languages. I didn't have that experience, but generally speaking, is really ahead of time compiler is the thing which we were looking at. And they have 2 editions. Community edition is completely for free, and enterprise edition costs you money, but you will have some kind of performance improvements there. Or you are in the Oracle cloud, then you will get even enterprise for GraalVM for free. I think the logic is clear. Oracle want to lock you with GraalVM and with Oracle Cloud. That's totally fine. But nevertheless, we are talking about AWS Cloud. So general architecture of the GraalVM is that you see the Java hotspot, in the bottom, and then you have Java compiler interfaces from Java 8. And on top of this, you have Graal compiler, which can compile all JVM languages like Java, Kotlin, Scala, Groovy, and so on. And then you have Truffle framework, which allows you to compile Node.js, JavaScript, R, Ruby. Not relevant for today. You can even have some kind of Sulong LLVM on top of this, even to bring C, and even Fortran, Go, and so on to the GraalVM, but it's out of scope for today. What's really interesting is this substrate VM part. The substrate VM is nothing else as a head of time compiler, and probably you know what it is. And with the head of time compiler, you have some kind of closed world assumption. There you have to put all classes, GDK and substrate VM, and build native image from this. So you have to find out all reachable methods, fields, and classes to be able, to compile this, that it will run. So you have Mac and Linux, and since recently also the possibility to run this on Windows. Of course, the situation is, what is with the reflection? We have some kind of application which call class for name and so on, and how can substrate VM figure out all accessible classes and so on? Sometimes it can't, so you can put them statically. If you have such situation in the file, then they will be packaged with or will be compiled with a head of time compilation, or you can do this job with substrate VM. So write test that this all these classes will be loaded, and then run the test, and then GraalVM will capture this in this special detail for you, so you don't have to write this. So there are things you have to deal with, but the situation is all the classes should be compiled with the head of time compilation. Otherwise, you will experience things during the runtime. So this is the situation how it looked with GraalVM and with Java. Normally, you have Java dynamically executed, and with GraalVM on substrate VM with native image is Java also natively precompiled, and there are other things which are dynamically executed. You will also have a basic threading, basic garbage collector, everything within native image with substrate VM. But Java with the native image is the precompiled. So what does this bring for us? So Java function compiled to the native executable, and executed on substrate VM, they reduce cold start time. So if you have everything and they pre-initialize things, if you build native image, so the start time is really the matter of several milliseconds, something below 100 milliseconds. This is normal. And of course, you have low memory footprint because you only have packaged precompiled things that you really need. Everything else is not there. And and as we know, there's some kind of state we want to achieve. We want to reduce cold start times, and we want to reduce memory consumption, memory footprint. But if it were so easy that probably everybody will use this, the current challenges with native executable and GraalVM is most cloud providers, they don't offer GraalVM as execution runtime. So you see only Java 8 and Java 11, but GraalVM is the separate installation. So it seems not to be possible, but cloud providers like AWS, they offer custom runtime option. And what it is, that's the possibility to bring your own runtime. And that's something which was released, you see, in the end 2 years ago, I would say. And it looks like that you can bring then your native executable as your own runtime. And for this, if you deploy your Lambda, you can package this as function zip. And what should be there? This Bootstrap. And Bootstrap is nothing else. This is the default name of the file where the runtime will be looking at. And this Bootstrap should be the native executable, or it should call the script which contains the native executable. How to create it, we'll be looking with GraalVM, but with the Lambda custom runtime, there is a possibility to bring this GraalVM runtime, then bake it in the native image also and deploy the Lambda. But of course, you have to manage your runtime there. So you have to have scripts for deployment and so on. But two more slides about GraalVM. You have the options to build with just-in-time compiler, as we know, and also with AOT compiler. So just in case if just-in-time compiler with garbage collection and so on can be improved there to become a better fit for serverless, then you have both options. And of course, everything in our life and everything that we do has trade-offs. And you see the trade-offs with ahead of time compiler. It's start time speed, it's low memory footprint, and it's small packaging. Yeah, this is something which is everything is relevant for serverless. And with just-in-time compiler, you have the trade-offs. You will receive peak throughput and reduce max latency. So just for I would say for server application, it's the better fit. But if you want to have peak performance in your Lambda functions and use ahead of time compiler, GraalVM offers something called profile guide optimization, that they observe your function and then optimizes that we also know with just-in-time compiler. The thing is, the feature is only available currently with GraalVM Enterprise. So that there is no solution currently with another edition. Probably will come something. So, but generally the function should be short-lived, and then even the container, the function, the container will be reused, but only the cloud providers don't release the numbers. But even after 1 hour of the container, it will be released and will be thrown away. So then the new container will be started, and then you have one-time cold start and so on. So it doesn't make too much sense to aggressively optimize the functions, because the container is also relatively short-lived. It's nothing that we see with server applications that you can have servers for months and so on. So within functions, it's about minutes. I don't think that it's more than 1 hour currently. So the question is, okay, I have GraalVM support, but I like to use frameworks. They take so many heavy liftings away, and I don't want to play Java code. I need something to with dependency injection and so on to ease the things. And I know in the announcement was said that I will be talking about Micronaut and Quarkus and Project FN. It was my error, my bad. I will be talking about Spring Framework and Spring Boot. So Project FN is function as a service. It's a separate project, so it was my fault. We will be talking about these frameworks which support GraalVM and which support native imaging. But generally, we will start with some general things of how we deploy our solution to AWS. We need some prerequisites installed. So one of the frameworks of your choice, Java 8 or 11, Maven or Gradle, and we need tools to be able to deploy or local test our functions with AWS. You can use serverless framework, it doesn't matter. And what is really important, custom runtime, there should be Linux executable. This is the requirement for AWS. So you can bring Windows executable. You can build native image with Windows and Mac, but Amazon requires only Linux executable. And then you should deploy this Linux executable to your custom runtime. And we saw this is the function with Bootstrap, which should be packaged like a zip. And if you use AWS SAM for this is how it looks like. You see this, you have built your function zip, and then you say handler runtime, and it's runtime provided. So it's not runtime Java 8, Java 11, Python, and so on. It's provided, and that means that this is custom runtime. And then you should point out where your executable function zip is there. So now we will briefly see, it won't be demos because ahead of time compiler, they take minutes. So I will show you how to do things with all these 3 frameworks, and then I will give you links that you can try this out by yourself. Um, Firstly, we will start with all three frameworks are really not only for serverless, they are for building microservices. So serverless and ahead of time compiling GraalVM is only one aspect. So this is not the introduction to your frameworks, but we will all understand the framework. And I also use this same example to generate some kind of invoice uh, for our customers, but the business logic doesn't matter. So how I can write function, Lambda function with Micronaut, I have to declare my function bean with some name, and then I can derive this from Java 8 function interface and just implement this. So you don't see any AWS specific logic there. So you don't see any GraalVM logic. Here, this is pure business logic. And yeah, you can write the test. You can annotate this with function test um, for the client. That's an interface, so that the proxy will be generated. And if you write the test, then you annotate with Micronaut test, and you inject this client, which we have declared there, and then you can simply instantiate your object and then use the client to apply the thing. So you can test this locally. And what I find cool with Micronaut, you have two options. So then you see these dependencies are there. Micronaut function LWS, so very is a magic behind the scene. But what is really cool, you have the option to use Micronaut annotations, which I showed you, but you can also use your Spring Boot annotations. So you can really write even Spring Boot application, and then the annotation processor can process this to Micronaut annotation. And Micronaut doesn't use reflection and so on. So everything, it will be Micronaut application in the end. But if you are familiar with Spring Boot, you can use it. The problem that I see currently with Micronaut is that there is no Maven plugin to build your native image. So you have to package your application, and then you have native image should be installed anyway, but you have to do this manually and build this native image from your command line. This is something which I really think it's not the perfect solution. We will see that Quarkus and Spring Boot have solution for this, but it's something like if you have your application, you have jar, then you have to build native image on Linux, so you will use Docker or something like this, and then package this into function zip, rename the native image to Bootstrap, and yeah, that's the missing step. That there is the open issue, and I think it will be handled. So that's everything. I won't dive deep into Micronaut. The interesting thing from Micronaut is that the developer, the main developer, the founder, Graham Rocher, we know him probably from Groovy and so on. He joined Oracle several months ago. So I don't know how to interpret this. What does it mean? If the Oracle will somehow some kind of having the cooperation with Micronaut and will probably rely on Micronaut or improve things there, I don't really know, because he's still working on Micronaut. But interesting information. Quarkus is another framework with the same purpose, microservices, serverless for Java, but it's the Red Hat and IBM which support it since 1 year or since even 1.5 years. The same situation. If you write your Lambda function, I choose different approach. Now we implement the Amazon SDK, so you don't see any Quarkus logic in this business logic. So the same thing, but this time Amazon interface, then this one method handler interface with some business logic. So which I really find it cool that you don't have some framework stuff within your business logic. And if you want to test this, the similar approach, annotate with Quark test. Now you have dependency to Quark, and then they provide Lambda client to do the job. So you don't instantiate client like interface and then inject it like with Micronaut. Different approach for the same thing. So invoke and then the input and then the output, and then you can test your things out. What's really cool is that you have the Maven plugin. here. So you have profile, which is called native, and then you have plugin Quarkus with the goal native image. And if you yeah, simply enter maven -p for profile native, and then say package, then this native image goal will be executed. You can also have maven zip plugin to zip things out, but this step will build the native image for you. Of course, you have GraalVM to be pre-installed, and you have native image. This is extra installation, depending on your platform, Linux, Windows, and so on, should also be installed, but then everything should be done. But it takes minutes, 3 to 5 minutes. That's something which is normal. So there are additional features. So you have website like Spring.io for creating the app. With Micronaut, you have only the command line. You have the integration with API gateway to put some HTTP traffic, and you have Funky. What is Funky? Yeah, that's what Quarkus tries to bring up the serverless strategy to write portable Java application across other cloud providers, not only AWS, but also Azure, Google Cloud with Knative, and so on. I probably don't think that the portability of your logic between cloud providers is a huge issue. Of course, one cloud provider can raise the price, or because of privacy sheet or something like this, we may become difficulties with one of them, but we at AWS, we have full lock-in into AWS, and yeah, we would try to have everything possible to take everything possible from this cloud provider. So the portability is not the priority #1 for us currently, but it may be the issue for you, for your business, if you're in the banking and something like this, and you are thinking, okay, if something goes wrong, how quickly can I move? Then Quarkus Funky could be one of the solutions, but it's probably, yeah, like standards, they have also the drawback, so you can't use any managed services from your favorite cloud providers and so on. So this is some kind of minimal solution only possible. And the same thing with Funky, you can have AWS Lambda and also API gateway, but it's still in beta. It's very, very fresh. Now we will come to the third child, Spring Boot and Spring framework and Spring Boot framework. And the situation is, of course, yeah, that's probably the favorite framework, but they started to think about the cooperation with Graal and with the head of time compiler very late. So other two frameworks are really ahead of time comparing to Spring Boot, and they are currently working, and they have started their Spring GraalVM native project, which is currently in experimentation phase, and they promise to release this in March, but also as experimentation, as far as I understood, and they will improve this, so it will be probably available probably 1 year later, starting from now. So if you see how this can be implemented, also really the same thing. This is our Lambda. This time we implement the function interface from Java 8, and we have business logic, so nothing special here, no dependency. Even I see here auto-wired. Okay, I have auto-wired my service. That's the only Spring framework dependency here. And currently you have to write application class and register your beans. So you see it here, demo application, we will configure it, and you see this annotation, Spring Boot application with proxy bin method false. It's currently required. The situation is to turn off the CGLib because GraalVM only supports GDK proxy. Probably it will disappear. And here you have to register your bin. So your Lambda function, which we created 1 step ago. So very complex logic to register the bin. You see a lot of generics and so on, but this step is currently required. And the same situation, you have Maven plugin. So profile native. This is GraalVM plugin for Spring Boot. Then you have to declare this demo application class. This is the class which we created here to register bin. You can have build arguments and additional arguments if you want to do things. And the same situation, you have native image goal. So you can call this the same with Maven minus profile native, which will switch the profile. And if you say package, then this native image will be executed. So this, if you see, you will just very similar thing to Quarkus, but just one more step with application class and bin registering. But I think that we will improve the things because this is very young project comparing to Micronaut and Quarkus. So the wrong direction. So I won't compare all these three frameworks because I'm not interested in comparing programming model, database, test support, because I'm only focused on native image part of this. You can see here the comparisons for the application themselves, but it's probably the comparison of the day because they improve steadily. But what you see that Micronaut and Quarkus are, I would say they are near by each other for native image size, startup type, and heap size. And Spring Boot has really much higher startup time and much higher heap size, but they improved a lot since last presentation from the beginning of the year. So I expect that there are a lot of smart people working on improvement because people understand that many developers rely on Spring and so on. But currently, Micronaut and Quarkus are ahead if you try to use to rely on the things. Conclusion from my side, GraalVM and frameworks are really a powerful tool with a lot of potential. But in combination with native image, currently not without challenges. So it's easy in the presentation, build a native image and everything works. But the first thing, Lambda custom runtime, you have to manage this runtime, and this requires Linux executable runtime. So people from Windows world and Mac world then have to have Docker and then build the images within Docker, within dependencies to Linux and so on. Yes, that's what I've done. And there are plenty of exceptions. So I have tried to build even simple things, but then building native image, you have to deal with a lot of exceptions and understand them, probably exclude dependencies. So even simple function, the ramp up phase, it's really not that low. And you have to experiment with a lot of GraalVM flags like initialize at runtime or delay class initialization to runtime to exclude things like internet address and so on. So there are a lot of, I think I posted here Stack Overflow page that you can read about all these things. And I also went through all the steps to improve and to be able to build the native image. But it's nothing that it's 1 minute and it's done. And of course, building of native image means that you wait in your build phase. So just small microservice and maybe waiting for 3 minutes to build. But then it's very fast in the execution. So this is the trade-off. And once again, less dependencies is more because we tend to include many things and then we have to deal with all these exceptions there. So probably it's currently not the time to use this in production, but it's really important to stay informed, but because I really see huge potential with native image ahead of time compiler and bringing Java as a language. But really, we will see how we'll go. If you want to try yourself, you have a lot of materials to demo from different frameworks, everything with AWS, and you have here from Amazon itself some kind of repository that you see examples for all three frameworks. So you can try it. And probably the last thing, in the end of the April, Oracle announced the Project Laden, and the goal is really similar as for the GraalVM, as you can static image, ahead of time compiler. So all this functionality that we know from GraalVM should become the part of OpenJDK. But they say this is kind of standard, so they don't plan to merge OpenJDK and GraalVM. What is the separation? It's not really clear for me currently, but Mark Reinhold answered the question that they want to provide standards that also GraalVM should use. So that will probably take years, but it will be really cool if you can simply select your Java as execution runtime and then build the ahead of time compiler without using of custom runtimes, without using of GraalVM, all these things. So everything is packaged within OpenJDK, and your cloud provider allows you to select this when writing your function. For us, it's Java. So that's probably everything I wanted to say. I know that it's late, and thanks for invite and thanks for listening. So this my first experiences. I know that it was also the first run of the talk, so probably there are a lot of questions, and I will be really happy to answer them. So thank you very much.
Yeah. So thank you very much, Vadim. It was great to listen carefully to all the presentations. So I've learned a lot of things, and I have some things to share with you. So there are a few questions, 3 questions we have already in the Slido, and also a few people commented things here in the Slack. No, it's just like in the Zoom channel, for example, that it seems that apparently Graham is still working with Micronaut. So he's working from Oracle, but involved in Micronaut. So at the same time, it seems that he's working as expected with OCI. So leading the team, etc. So that's one of the things. The other thing is that it seems that Micronaut already moved to a different version, and these things about the plugin for Maven. There is a one for Gradle, so they are working on another version for Maven. So there are things that are improving, let's say, a lot. And are related with the questions. Let me see. So there are some questions that the people say, Dijan say, how would you compare hosting costs? So on-premise versus serverless, and how hard is to properly plan budget costs with this new paradigm from Serbia?
Yeah, this is, I think, is a general question. So at Epilapse, we are really, it doesn't depend on Java, but we try to be as serverless as possible, because the situation is that you can, of course, management wants to know how much does it cost. But the thing is that we should also have total cost of ownership. So going to the cloud, and we are full lock-in with AWS and trying to offload the things with serverless. It's really hard if you write microservice application. There are a lot of things you have to consider, all the things, deployment, monitoring, alerting, and so on, scaling, auto scaling, infrastructure management, and so on. These are also things that you spend time. And it's the topic of another talk from me, measuring and increasing developer productivity with serverless, which is serverless related, not Java related, where I explain what is the total cost of ownership of your application. And it's really, I think that with the servers generally, you can offload your things to your cloud provider to have more focus on business value. So this is probably the thing. It's not related to Java itself, but generally it's comparing apples and oranges. You compare the bare metal with cloud instances with containers, and then with serverless. Everything has its use case. Probably you don't. It's not possible to build 100% serverless application, but this is how we think. We are starting to think how to build it as much as possible serverless. And if we see some restrictions, then it's totally fine that we use containers on even plain EC2 instances. We use Beanstalk, this platform as a service on AWS for some cases, and it works perfectly. So sometimes we will switch, but generally we want to offload everything, because I mean, infrastructure is not the core competence probably of many of the companies. For AWS, it's the core competence. For data center, it's the core competence. But infrastructure peaks, dealing with peaks, it's really hard. And we are in the business with photo products where we have huge spikes on the Christmas. So for 1 month with all events and so on. And then we have to think how much to reserve the capacity. It's really boring.
Yeah.
Yeah, because it's also spending money you don't really know. We are even in business to business, so we have to rely on forecasts from our partners. So they don't know, so how can we know? And but we have to pay for infrastructure. But just yeah, it's probably another topic. It's really difficult to compare. We can talk on Twitter or on LinkedIn or via email about this. It's probably much broader topic to use serverless or not.
I agree, but I think it's the question is not so easy to to answer. At the end, is like how you handle one completely, let's say, on-premise, and it's a completely different paradigm. So yeah, I
And even skill sets which are required to build them, how you are doing with DevOps. So with serverless, each team should deploy and monitor and so on. So there is no other chance. So just
yeah
everything should be automated and so on. It's also depending, is it possible in your company to do this just because yeah, the cloud is not the favorite thing for system administrators. And if you say to them serverless, then yeah, where is the server? Where I can install agent? Oh no, I don't know what to do. And
Mhm.
just these discussions, they are real discussions. There are a lot of things to do, even for system administrators, like chaos engineering, game days, alerting. There are a lot of things, but they are different.
Yeah.
Just that you should keep this in mind.
Yeah. Thank you. So there's two more questions. In your experience, is GraalVM a must, or we can deploy simple functions without it?
I think GraalVM is not ready currently, but it will be way to go. And for your, of course, you can deploy your functions, but the question will be what will be the costs. So this cold starts and these things and will more memory. If you have some application, and our first application was revenue share calculating, which will be triggered one time per month on the first of the month in the night, and when it's done, it wasn't cost sensible. So we built
Mm.
it with Java. We didn't think about cold start, and we paid 10 euros for this application per month. So we just nothing to optimize. Every minute which I optimize is wasted minute. Then it's okay. But if you want to build high scalable application and use only Java, then you will inevitably have to think about the costs. And then you will probably run in the situation then Java is not the perfect language for this. But of course, as I told you, Python and Node.js seem to be more popular. But again, you have to think about yeah where you're more productive. So this is money versus productivity,
Yeah.
and then just it's very difficult to compare without knowing exactly the use case and the situation. But of course, if you spend 1,000 euros and now you are serverless on Java, you are productive, but you are paying 1 million, then probably your chief financial officer won't be happy. And just it's another discussion then.
Yeah. So thank you again for the answer. I think there are here two questions. So uh, one is about how to work in local, no? So basically we have things in someone else's computer, no? And serverless is something that is out of of let's say a host of workstation. It is possible to run everything, let's say, without having to deploy in the code in AWS. So it's possible to run in local without internet, for example.
It's possible with LWS SAM. This is serverless application management, I think, or even with serverless framework, you can run and test lambdas with local. Then it will be with Docker functions. But of course, if you need more sophisticated services like SQS and so on, so it's not possible to test everything locally.
Mm.
And the situation is that generally within the cloud and general within serverless application, you tend to test everything in the cloud. So you automate everything and you
Mm.
deploy everything. And we have the situation that in our company, each team has its own LWS staging or test account. Because with serverless, this is that cheap. You pay only for what you use. And plus the storage, but we don't have too much storage in our staging. So generally speaking, even each developer can have its own test account. He should or she or he should think about how to throw things away. But generally, it's possible. But this is something I would say. This is a shift of paradigm that you can't test locally. It's not. Yeah, you can debug, and so you have to think differently. But simple Lambda functions you can test with SAM local or even serverless. There are ways to do this, but with some limitation because each AWS service has limitation how much puts, gets, accesses, and so on. And this is not replicable to your local environment.
Yeah.
So just if you want to do some quick functional test or unit test, then it's okay to test it. If you want performance test, last test, stress test, now that's probably not.
Yeah. Yeah. I see. I understand. Makes sense. So, and the last one, if I'm not wrong, by the way, guys, I mentioned if it's possible to turn on your camera, probably. But thank you, Ivan, by the way, to see some faces. Probably is going to be helpful for Vadim to see somebody out of the presentation. But um, so the last question that we have already is that what it is. Yeah. What about the cost of building the native image? How much time and power it takes to build a simple function, no, to AWS? So it takes a lot of effort, a lot of resources just for safety and sending to the cloud.
That's true for GraalVM. That's generally true for GraalVM. But of course, if you say okay, it's not so cost sensitive, and I can encourage you to start with some kind of project with some kind of internal tool which don't need to run 24/7. Then you can deploy simple Java functions without GraalVM. You will overpay some cents. It's nothing. That just this normal thing. You write function, you automate everything in the cloud as it also should be. Then it's really no effort. GraalVM comes into the scene if you want to save costs, and you really can save costs. That's the potential of GraalVM. Otherwise, and we have the situation that many Java developers, because of the way to the cloud, they became Node.js developers or JavaScript developers. Of course, it's not the way to go for everybody, and we are here in the Java community. So there are a lot of smart people who are currently thinking how to bring Java to the serverless platform. Yes, because it's really a challenge.
Okay,
I
so
hope I answer questions. I read the chat in parallel. Sometimes, yeah, it's not clear if I understood the intention of the question. So, um,
I think you already asked answered majority all of them. There are some that are not easy to answer, like how to compare different paradigms. But in terms of the other ones, I think you already replied more or less. So I don't know if anyone has any other particular question. If not, I think we can stop it here. And then I have to say thank you once again, Vadim, for your time here and for sharing your knowledge.
yeah,
I hope at some time we will meet. I don't know your country or our country, but if you are coming to Spain, I would say that you have to sing a song by Julio Iglesias, probably.
he is 77, I think, and
Okay, makes sense. I don't know many songs by Julio Iglesias, so
yeah,
so I don't know if anyone has any other particular question or wants to add something. That's the time.
probably if you will invite me sometime later with another talk, then I will try to do it in Spain. In Spain,
Yeah,
so yes, it will be probably the much bigger challenge for me, but yeah, but I like challenges.
we like so. Yeah, so thank you, Vadim, once again, and thank you all the people that have been here and the people that are following us in YouTube. And I hope to meet you all at some point. So have a great afternoon, people.
So thank you
Enjoy.
very much. Ciao.
Bye.
Bye.